So, you've been hearing of the Coulomb's law. So, in this video, let's actually talk about it. Are you ready? Now, there is this French physicist named Charles Coulomb. From his experiment, he brought out a law which is Coulomb's law. Is that clear? Now, before I state this Coulomb's law, let's remember the fact that you that is watching this video, you are made up of what? Atoms. Now, what are atoms? We were told that atoms are small indivisible particle or part of an element which can take place in a chemical reaction. Now, from the structure of atom, we were meant to know that atom is not indivisible. Yes, it is made up of subatomic particles named protons, electrons, and what? The neutrons. Is that clear? Now, these protons, according to the charges, they are what? Positively charged. These electrons are negatively what? Negatively charged. And the neutrons are what? Neutral. Now, what does it mean that neutrons are neutral? It means that for something to be neutral, that protons, the number of protons balances the number of electrons. So if the number of protons is 8, that's plus 8, and the number of electrons is what? Minus 8. Plus 8 minus 8 would definitely give us 0. So it means that that thing is actually neutral. It has no charge. Does it make sense? Now, what I'm trying to bring out here is this. So from Coulomb's law, we're told that when two charges, listen up, we are considering two charges, 2-point charges, that are charges that are very small. When two charges come together, now it is either these two charges attract themselves or they what? They repel themselves. Now, when will they attract themselves and when will they repel themselves? So imagine a situation whereby I have a positive charge and equally I have a negative charge. Something being positively charged means that it has more what? Protons than electrons. And something being negatively charged means that it has more electrons than protons. I hope it's clear. Now, we are told that when these two small charges come together, they are not when they come, that's when they are placed to some extent closer, that they had to what? That they would either attract themselves or they repel themselves. Now you see this, I have a positive charge and a negative charge. In this case, they what? Attract them what? Selves. Is that clear? So this will tell you that this positive charge will attract this one with a force. Now, this force is the same thing that this negative charge will attract this one with equally the same force. Now, from Newton's third law of motion, we were told that action and reaction are equal but opposite in direction. So, when this acts on this, this reacts on this, but their directions are what? Opposite to each other. Is that clear? Now, in this case, what's the force there? It is force of attraction. Why is it force of attraction in this case? Because they are of unlike charges. Now, if you imagine a situation whereby we have protons and a what? Proton, they will do what? They will repel themselves. This one will move this one, this one will move this way. The same thing happens when I have a negative and a negative charge placed together. They will equally repel them what? Selves. So from what we know that like charges that study the electricity, like charges will what? Repel themselves, while unlike charges will do what? Attract themselves. Is that clear? Now let's go back to Coulomb's law. Charles Coulomb stated that the force of attraction or repulsion between point charges is directly proportional to the work product of the charges. Let this one be Q1 and let this be Q2. So it is directly proportional to the product of the charges and inversely proportional to the square of their mean distances apart. Is that clear? So I have that F, if I remove this, F is equals KQ1 Q2 all over what? R squared. This is almost the same thing like universal gravitational law. Is that clear? Now, this could be force of attraction or this could be force of repulsion. And this formula square is another inverse square law. I hope it makes sense. So this force of attraction is actually in what? In Newton, not only force of attraction. Remember what I said, it could be force of attraction or repulsion depending on the two charges what involved. If they are unlike charges, it is actually force of what? Attraction. But if they are what? Like charges, it becomes what? Repulsion. Please don't forget. Now, Q1 and Q2 they are charges, so their unit is what? Coulombs. They are measured in what? Coulombs, normally written as C. Now, R is distance, always what? Meter, dash square meter. Is that clear? Now, this K now is actually a constant. Now, this K is also given by 1 over 4 pi E naught. Now, E naught is permittivity of free space. Now, the value of K is actually 9 times 10 raised to power 9. The unit is Newton meter square per what? Coulomb square. So this is the value of K. Now, if you want to find the value of E naught, you can do that by yourself, and it will give you 8.85, I guess, times 10 raised to power minus 12 per Newton per square meter square Coulomb. Is that clear? So I guess I'm stopping here. By now, you should have understand or understood what Coulomb's law is actually talking about. That the force of attraction or repulsion between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of their mean distance apart. Does it make sense? So in my next videos, I'll bring out some questions. I will look at how to calculate them. Have a nice day. Like, comment, share, and follow Coaches Academy. Bye bye.